Hello, welcome back to the channel, and this is the start of a new series where I'm going to start looking at the science behind solar panels, batteries and green energy. And I thought I should start off with explaining some of the terms that you come across in terms of units. So things like what's a watt, what's a kilowatt, what's a kilowatt hour, how does this relate to things that we come across quite often, such as voltage, amps and joules, and even calories. So these terms get bandied around quite a lot and can make things quite confusing, because you might be looking at a battery system and they'll give you some sort of capacity in amp hours, and then you'll look at another battery and it will talk about its ability to store in kilowatt hours. So let's have a look at what these terms actually mean. And let's start off with just the word kilo, or mega, or milli, which you might come across. I've already got a series in my Maths for Nanotechnology, which I'll link up here, which actually explains these. But in brief, if you ever see the word kilo or K in front of a unit, it means 1,000 of those units. So a kilowatt is 1,000 watts. A megawatt is 1,000,000 watts. And a milliwatt is 1,000th of a watt, or something like times 10 to the minus 3. You'll see it. So again, if you check out those videos, you'll get more explanation there. So now we need to start looking into what's power and what's energy. And as you can see, there's probably a load of puns that I could put together here, but I'm just not quick enough to come up with them off the top of my head. But let's start off with energy. So energy usually has the unit of joules, and it's the measure of work done. So let's say, for example, you have a kilogram of water, which is a litre of water, and you wanted to heat it by 1 degree. The number of joules to do that is 4,100 and either 82 or 84, depending on where you look on Google. So that's the number of joules it'll take to raise the temperature of water by 1 degree. It's also called the Pacific heat, and it's also the amount of energy which is equal to 1 calorie. So that energy is can also be described in terms of newtons, and it's can also be defined as 1 joule is the energy or the work required to move an object 1 meter against 1 newton of force. So this is, you think about picking up a mass and you move it, lift it up 1 meter, and you're moving it against a newton of force, then that would also be the equivalent of a joule as well. However, we tend not to think about it in that terms when we're talking about electricity, because we're not moving something a meter, or we're not dealing with mass. So we tend to use the idea of joules in a different way. So going back to this idea of energy, we also have something called power, and these two terms aren't interchangeable. Energy is not the same as power. What power is the rate of energy usage. So let's say you heated your water by that 1 degree, so you use that 4,182 joules. If you did that in 1 second, so you put all that energy into that water in 1 second, you would have used 481 watts of power. If you'd done it over 2 seconds, you would halve the amount of power you were putting in. So the way you calculate power is you take your energy and you divide it by the time in seconds that energy was used. So for instance, if you look at your kettle, it's normally something like a 3 kilowatt kettle, which means that every second it is using 3,000 joules of energy. If you have a 1.5 kilowatt kettle, every second it's using 1,500 joules of energy. Therefore, it will heat the water. It will take twice as long to heat the water as the kettle of 3 kilowatts. So that's the idea of the difference between power and energy. They are related, and the idea is that power, which is measured in watts, or it could also be measured in joules per second, is the time it takes that energy to be delivered, or how that energy is being delivered. So we've come across the term watt and the term kilowatt, but what's a kilowatt hour? So this is a interesting term. If you're trained as a scientist, you don't often come across it. But a kilowatt hour is actually a measure of energy. It's so it's talking about the energy stored in your battery usually. And what it does is, because you have your idea of a watt, okay, it's basically a kilowatt times a unit of time, in which case an hour. So if you think about it this way, you have your watt, which is joules per second, so that's energy per second, and you're multiplying it by another time period. So those time periods in effect cancel out. So you actually just take it back to the state of being energy. It's just a bit of an odd one because you are dividing by seconds and multiplying by hours. So when we talk about kilowatt hours, is if you were running a device that you was using, say, let's say a kettle at 3 kilowatts, if you ran that kettle constantly for an hour, you would use 3 kilowatt hours, because you multiply the amount of time in hours that you're running that device by the power of the device. So that's the idea of what a watt is, what a kilowatt is, and what a kilowatt hour is. Something else that you might come across when they're talking about batteries is amp hours. So first of all, we have to talk about what an amp is. So an amp is the measure, or 1 amp is when 1 coulomb of charge passes a point in a per second. So what does that actually mean? So when we're talking about electricity, we're normally talking just about electrons. And an electron has a property which is called charge, and it has 1.6 times 10 to the 19 coulombs of charge on it. So for 1 amp to pass a point in a second, you would need 1 over that 1.6 times 10 to the minus 19, which is something like 1 times 10 to the 18. So that's a 1 with 18 zeros go after it. Electrons, so it's a million electrons passing a point in a second. So that's what an amp is. So it's basically a measure of how many electrons are passing a point in a second. An amp hour is how many electrons have passed that point in an hour. So you take your time for an hour and you multiply it by by your amps, and that then gives you how many electrons have gone past that point in that hour, and how many effectively you've stored. So it's not quite a unit of energy, and it's certainly not a unit of power, but it's somewhere in between the two. What you also have when you see things put in as in a unit of amp hours is they'll normally give you a voltage as well. So the voltage is effectively the force that's pushing the electrons. It's sometimes also called the EMF, or electromotive force. And if you take a voltage and you multiply it by an ampage, so you take a current and you multiply it by a voltage, you get power in the units of watts. So if you have 1 amp and you are having to supply that 1 amp, you are having to put a voltage of 10 volts on it. You have 1 times 10, so that would be the equivalent of 10 watts. So this is how it relates to power. So if you have something in your amp hours and you times it by a voltage, you have voltage times amps times hours. The voltage times the current turns itself into watts, and you end up with watt hours. If you divide that then by 1,000, you get kilowatt hours, and you've got back to your unit of energy. So this is important in terms of batteries, because the amount of energy it stores is actually dependent, and the amount of energy it can actually provide back out of itself is actually dependent on the voltage that is coming out of. So normally there's a nominal voltage that it comes out with, and normally it's about 48 volts. So from that you can get your idea of what your amp hours are in your battery. Why is this important? It's important if you're having to chain batteries together, because you need to try and match the same number of amp hours and voltage of your batteries together, which as consumers we don't have to do too much of, but if you're an electrical engineer then it does become important. So from a consumer point of view, watts or kilowatts and kilowatt hours is important, because this is what your bills from your energy supplier are normally measured in. I should also point out that gas, even though it's applied in the units of units, so you buy a volume of gas, that is then put through a conversion factor to work out how many watts and watt hours it is. So you can then compare it to your electricity rates. That's because when you burn gas, it contains a certain amount of energy, and how quickly you can burn it then turns itself into a power. And if you run that amount of gas for a certain amount of time, it turns itself into watt hours. So that's where all these terms come from. So hopefully you found that useful. We will be going back to these terms throughout the rest of these videos, which I'm hoping to release on Mondays. I probably won't release them every Monday. It's dependent on when I have time to make them and when I've got something to actually make. So these videos will cover like the basics of how a solar panel works, what the technology is inside these solar panels, where the future technology of solar panels are going, how batteries work, how that infrared heater upstairs we've got works. I'll be covering things like this. I'm hoping also to get interviews with people within the industries that use this, so from scientists and engineers, so you can get a true expert view on this. So if you are watching this and you are an expert in one of those fields, please get in touch. I'd love to chat to you. So anyway, thank you for watching, and I'll see you again soon.